Baker Museum. I value that, and I'm absolutely certain that the administration for the R.C. Baker Museum appreciates it also. So thank you. You know, there was a long period of time when people were more interested in surviving the night rather than celebrating the night in song. But I have a few tunes for you, and I'm going to ask you to have a little bit of fun with me. Let's see if we can name the tune and the artist that performed it. What's the name of the song?
Fly Me to the Moon.
Who did it? Yeah, old Blue Eyes. Let's try another one. Who was that, Ken?
Water Revival.
That's right. And the name of the song? Bad Moon Rising. Very good. Okay. Let's try another one.
And now the purple dusk of twilight time steals across the meadows of my heart.
You got it? Nat King Cole. Okay. And what's the tune? Stardust. All right, let's try one more. Just for fun.
Here comes the sun, here comes the sun, I said, it's alright.
I do think that I gave away the name of the song, didn't I? It's called what?
Here Comes the Sun.
And who's the singer?
Beatles.
Which Beatle? George Harrison. That's right. Well, congratulations. Let's go ahead and move on here. Let me introduce to you Stacy Anderson. Dennis, Linda, any relation? Stacy and her team have spent the last 20 years trying to figure out what it is about people that allows them to live to be 100. And so far, she's put it down to good genetics, diet, exercise, and doing something to keep yourself interested up here. What I'm hoping is that maybe if you get interested in Coalinga's celestial skies and spend a little bit of time outside exploring the nighttime, that you too might find something that piques your interest and allows you too to stay interested. What I would like to do is to make a distinction between astronomy and astrology. In our little cartoon, we have Astronomy 101, and the professor is asking, are there any questions? Hand goes up. Yeah, what's the difference between astronomy and astrology? And the answer is, well, astronomy uses a lot of math. And everybody's gone to the registrar. Astrology, which was a very big thing way back when, was based on the idea that everything was already foretold. Your future, your destiny, all of that was written in the stars. Astronomy, on the other hand, says we don't know anything, and we're going to have to figure it out for ourselves. Astronomy concerns itself with some of the big questions. How did it start? How's it going to end? Are we alone? How big is it? So, we are concerning ourselves with astronomy, and because of that, you can be a sun worshiper without actually worshiping the sun. We've come a long way. Did I do something wrong, Bill? Math is the servant of science. And there are two units of math that you and I can use to appreciate the nighttime sky. One of those is the speed of light, the other is a light year. Horned toads can blink, and let's say that we have a magic horned toad here. He can shoot a beam of light out of his eyes. When that horned toad blinks, the beam of light would leave his eyes, go all the way around the planet, come back and tap him on the back of his head before he can open his eyes again. 186,000 miles a second. To look at it another way, if you say 1 Mississippi, that's the amount of time that it takes for light to travel from the Earth to the disk of the moon. Now, if you were to try to cover that same distance in your car, even fudging a little bit on the I-5 speed limit, if you went night and day, didn't stop for fuel or anything else, it would take you about 4.5 months to cover the same distance. A light year is a number that we use to measure the distance to the stars. Outer space is really, really big. And when we speak about a light year, it's really kind of just a word because the number is so large. But a light year is about 6 trillion miles. The closest star that you and I can see out in the nighttime sky is called Proxima Centauri. And that's 4 light years away, or 24 trillion miles. And that distance, that number, is still smaller than the national debt.
Elon's working on it.
So, because of these distances, when you look in the nighttime sky, you are really not seeing the light from where those stars are. You're seeing where they were. The Hubble Space Telescope looks at distant galaxies back towards the beginning, and it is showing us light that is 13 million years old. So if you like collecting old things, go out and collect some starlight. Even dawn and dusk, the light that you see at sunrise and sunset is already 8 minutes old, because that's how long it takes for that light to boil off of the sun to get to the earth. You and I live in the suburbs of the Milky Way galaxy. We cannot see the center of the galaxy. It's back behind this cloud of dust and these stars. But we're fortunate in Coalinga because we live in an area of the country where we have relatively dark skies. So on a night where the seeing is good, you can see the Milky Way. And not too far out of town, there are very, very dark skies which will make the Milky Way and other celestial bodies just spectacular. We're fortunate in Coalinga to have that. How about a round of applause for Big Belly? In order to orient yourself to the nighttime sky, it's helpful to orient yourself to Earth first. Specifically, you need to know which way is north. When we take a look at the map of the city of Coalinga, you notice that the streets are oriented in two different directions. This is the early township, and these are later developments. Can anybody tell me why the streets are oriented this way? Yes?
Railroad. They're parallel to the railroad.
Parallel to the
Railroad.
railroad. Why didn't the railroad bother to orient itself to north and south? There's no particular reason for it to do so, right? What the railroad wanted to do was to get the cheapest, most efficient, frost-free route from Texas to San Francisco. Now, if you want to orient yourself to the nighttime sky, if you can imagine where Polk Street is, or Washington Van Ness, or Cambridge, those streets are going to run east-west. And if your house is parallel to those streets, then you can go out into your front yard and you know that that street is running east-west. Sunset runs north-south. And I think it's kind of an unfortunate name that it's called sunset. Once you've determined where north is, then to orient yourself, we are looking for the North Star, or Polaris. This is important because the North Star is then associated with this collection, the Little Dipper and the Big Dipper. The Big Dipper is going to be important as you go out and start exploring the nighttime sky. There are some other points of reference that are going to be helpful. If you're an observer standing somewhere on Earth, we know that an imaginary line going from the North Pole up into space will intersect with Polaris. Polaris is not a particularly bright star. It's not a particularly important one. But if you do that type of photography where you put the camera up and you do a long shutter exposure in the star's streak, there's one point where it doesn't spin. Well, that's Polaris. That's the celestial North Pole. Another location is directly above your head, which is referred to as the zenith. Now, you might think that the zenith is north of you, but it isn't. Depending on where you're standing, north is over there, and zenith is directly overhead. There may be something interesting over your head at the zenith. Then again, there may not. We have the celestial equator. This is an imaginary line drawn out into space. And the celestial equator would be interesting if you happen to have a very fancy telescope and you had to do some aligning of it so that the telescope would point in the right direction. Or if you happen to be a druid priest or priestess and you want to celebrate the equinoxes and the solstices, then the celestial equator becomes important. Finally, we also have the observer's horizon. And this reminds us that in the best of conditions, you and I are only ever going to be able to see half of the nighttime sky at any given time. It's a useful construct, a useful fiction, to consider Coalinga's nighttime sky as a dome with the stars being fixed points against that drapery. In front of the drapery, we have the moon and the planets that move back and forth. And this caused no end of heartburn to our scientific ancestors, because the idea was that the universe out there was a clockwork. And as a clockwork, everything was supposed to move in exact precision. And the planets didn't. In fact, the word planet itself means a wanderer. The problem was caused because the early thought was that we're pretty important. We're smart enough to be able to appreciate the nighttime sky, so we must be important. Where we're living must be important, so it only stood to reason that everything else out there spins around us. The problem with it was that the math never worked out. Later on, a Polish astronomer, Copernicus, reasoned that it's not the Earth that's at the center of our solar system, it's the sun. And once he figured that out, then all the numbers worked out. And so now you can predict where the planets are going to be. This graphic is kind of an interesting one, an old woodcut. What's behind the curtain? So let's say that you do develop an interest in the nighttime sky. I remember a student once saying to me, "Mr. Mitchell, I don't like classical music, I don't get it." Why? Because they say that when I'm listening to some kind of classical music that I'm supposed to think about certain things, and maybe I'm not. And I don't like the idea of me being so dumb that I can't think of what the music is supposed to make me think about. Well, that music is 200 years old, and what they're trying to get at is it's just a suggestion. And times change. But by the same token, anybody can go out on the nighttime sky. You can recognize this, right? But I'll be darned if I can look at this and I see this. And for the other 87 constellations out there, you may be hard-pressed to look at that group of stars and to see an archer or a lion or a bear or anything else. So why do we have these? It's just a story well told that's come down to us from antiquity. And in a way, it's our method of being connected to our past and to show respect for the people that preceded us. Understand, too, that when we have our constellations, that's what we recognize on this side of the Pacific Ocean. If you happen to be over there all those collections of stars have a different meaning altogether. These are the seven sisters. For us, we call them the Pleiades. What do they call them in Japan? Subaru. Which in Japanese means unity. Is there anybody here that goes to high school? Anybody here in high school? Are you aware that there is a new terrorist group that is now infiltrating the high schools? The name of the group is called Al-Jabra. When you start to explore the nighttime sky, and you start to learn the names of the stars, you see that many of them have foreign-sounding names. I think the one that we're most familiar with is good old Betelgeuse. But there are many others. How do they get those names? Well, it turns out that the Arabs are pretty darn smart. What they did was they went out, the Arabian astronomers went out to the desert, and every night for an entire year, they'd look at the horizon, and as the sun sets, they would read the horizon and see a new star or a number of stars, and they would give those stars names. The following night, they'd go back out again. Those stars had risen higher in the sky, and there were new ones on the horizon. So you do this for an entire year, and that's how these stars got their names. Oops. Now, the other night, I was out with my wife, Sherry, and I said, "Hey, Sherry, check out that star up there." And she goes, "Which one?" I said, "Well, it's that one up there." And she says, "I don't know what you're talking about." So I reach in my pocket, and I get my handy-dandy little pointer here, and I say, "Well, it's that one right there." The point being that having a tool is all well and good, but you don't necessarily need to have that. If you make a fist and the bottom of your hand is at the horizon, you should be able to make 9 of those going all the way up to the top. So every fist is 10 degrees of sky. So you can see a star up in the heavens, and by using fists and pinkies, you can come up with a pretty close approximation of where that star is. So if you're sharing the nighttime sky with a significant other, you don't have to get into any kind of an argument trying to figure out which one of those stars you're actually talking about. So these are very handy hand signs. This is also a very handy one. This is the universal sign for "It's late, I'm hungry, how about a snack?" Now this, my friends, is the key to the nighttime sky, the Big Dipper. You don't have to have a telescope, you don't have to have binoculars or anything else in order to start understanding and enjoying the nighttime sky. After all, people were doing astronomy for ages before telescopes and all the rest were invented. The key is the Big Dipper. You can draw imaginary lines from the Big Dipper to other bright stars, and those stars themselves are associated with other constellations. We see in the handle of the Big Dipper, it's kind of an arch. So one method is to Arcturus. Arcturus is an important star in Bootes. Bootes is actually the constellation of the herdsman. If you do another imaginary line, it'll take you to Deneb. Deneb is an important star in Cygnus, or the Northern Cross. Follow another path of stars, and it'll take you in the nighttime sky to something that looks like a W certain times of the year, looks like an M at other times of the year. What constellation is it? Cassiopeia. That's right. And that does not look anything at all like the Queen, does it? But again, a story well told. So my point is this: if you can locate the North Star, you can locate the Little Dipper. If you can locate the Little Dipper, you can locate the Big Dipper. Once you find that, then you can start doing what is referred to as star hopping. You don't need a fancy telescope and all the rest to start doing that. You can explore the nighttime sky by hopping from star to star to star. And in time, you'll start to be able to see more easily these collections of stars, which we call the constellations. There are some big targets, which for us who might be interested in astronomy, you don't have to have the big fancy telescope. The sun, our own resident star, is one of them. You can do some observing with the sun. There are things called transits. In this image, we have the International Space Station is transiting or traveling across in front of the sun. The planet Venus will transit across the front of the sun. Of course, everybody knows and appreciates solar eclipses, and there are also sunspots. Do not let your children try to look at the sun through a telescope, anything like that. They'll get instantly blinded. I don't even recommend using welder's glass for that. But there are products. These are solar binoculars. You hold these up to your eyes, you cannot see your hand in front of your face. Everything is pitch black. But if you hold them up to where you can see the disk of the sun, it's very comfortable viewing, and you can see the sunspots. For additional fun, if you keep a little notebook of that and use a quarter or something to draw a circle, you can keep a record of the day and the time and what you actually see as you're exploring Coalinga's skies. I remember somebody who got a chance to look in a telescope for the first time, and they saw the moon, and their response was, "You mean they don't charge for you to see that?" They were so impressed. You could spend your whole astronomical experience just studying the moon, and who knows, there's probably a crater up there that has your family name on it. There's a lot to know about the moon, but briefly, if you have a new moon, that's no moon at all. And then, as the month goes by, the moon gets brighter, and then it gets dimmer. As it gets brighter, it'll get brighter from the right. That's called waxing, just like candle wax. And as it gets dimmer, that's called waning. There is a phase of the moon which is not quite halfway. It's a little more bright than halfway, or it's a little less bright than halfway, and that's referred to as a gibbous moon. A gibbous moon. Your homework is to figure out why artists don't paint a gibbous moon. We know about the man and the moon, and part of the features of the man and the moon are the Maria, or the lunar seas. This one happens to be called the Sea of Crisis. There are others like the Sea of Tranquility and so forth. I mention the Sea of Crisis because just 13 days ago, we successfully landed a lunar lander on the Sea of Crisis. This is Firefly Aerospace's Blue Ghost lander. Here is its shadow, and it's taking a picture of Earth from the moon. A couple of days after that, another lunar lander landed on the moon, was not quite as successful. It landed in a crater, tipped over on its side, and unfortunately, the solar panels landed on the wrong side. So that mission is essentially over with. Planetary astronomy is probably the prime reason why people go out and buy a telescope. Once you have seen one of these wanderers with your own eyes, it's something that you can mark off your bucket list checklist. That's the Earth. It is a thrilling and unforgettable sight the first time that you put your eyes to the glass and you see the rings of Saturn for yourself. They can't take that experience away from you. It's real, it's there, and you can repeat the experience. It's really profound to be able to know that it's out there and it's not all just in pictures. There are some other things in Coalinga's celestial skies that are of interest to us. Comets and meteors, satellites. This is a picture of a bad star. Going back to the idea of the clockwork universe, everything is supposed to be in a stately procession. So when a star comes out of the nighttime sky and misbehaves like that, that was an omen that bad things were surely going to happen. The name that they give a bad star is called disaster. So let's say I got you interested in exploring Coalinga's nighttime sky. Maybe at some point you might ask yourself, well, can I actually do any kind of science? And the answer is yes, you can. Because professional astronomers are dealing with those questions. How big is big? How did it start? Where's it going to end? In the meantime, there are spots forming on the moon. These are called transient lunar phenomena. Maybe a meteorite hits the moon. Maybe there's a moonquake and a bright spot develops on the moon. It's reportable, it's scientific, and it happens. Doesn't happen all the time, but if you're diligent, perhaps you too can observe one. If you are bucks up and you want to run with the big dogs, you can go comet hunting. In 1994, Shoemaker and Levy determined that a comet was breaking up and it was going to impact the planet Jupiter. Their names go on the deathless rolls of science now. So, you start getting involved in astronomy, and it's not very long before you want to start considering what kind of equipment can I get. I'm going to give you two pieces of advice. The first piece of advice is that the most valuable piece of astronomy equipment is the equipment that you actually will take out and use. Some people want to go out and buy a great big telescope, they use it a time or two, then it sits in the closet. That's the end of that. But if you have something that you can take out and you can use because it's relatively easy to set up and it's serviceable, that's a good thing. The other little secret is this. People will buy themselves a telescope and say, oh boy, I'm going to go out now and I'm really going to take a close look at those stars. And they're surprised and disappointed because the stars look like little twinkling points of light. And when you look through a very big high-powered telescope, they're still little twinkling points of light. They're that far away. My friendly advice, avoid using welder's glass to look at the sun, and avoid purchasing a department store telescope. The real expense in a telescope is not so much the glass and the lens, it's the mount that the telescope is on. Because if the mount is shaky, it's all going to wobble and you'll very soon get tired of that. So where do you go? Well, here in Coalinga, you can start in your backyard. Try it. Or go to a park or a roadside. We have Central Valley astronomers who like to hold forth over in the Fresno area. They go up to Millerton Lake, and on occasion, they'll go up into the mountains. There is an indescribable pleasure in being able to look at the nighttime sky and the celestial objects and say to yourself, I get it. I understand it. And it doesn't matter where you are. You can orient yourself to those friendly stars. You get it. But it's not easy. And I say it's kind of like climbing a mountain. It takes some effort to get up there, but once you get to the top, the view is spectacular. I'm going to turn the microphone over now to Mr. Bill Lewis. Thank you for your attention.
Okay, well, I've been into astronomy for quite a while, and but unfortunately, I lived in the Bay Area, in a very populated area, and there was a lot of light pollution, and it made it really difficult. I mean, you could see the moon, you could do the sun, and then when I went to work in Southern California, I joined an astronomy club. We built a small telescope, and we used to have to drive 100 miles to get good visibility. There's just so much stuff in the sky, and it really makes it difficult. But we have a gift here. Okay. This is I think I'll get up here. This is a map of Central California, and oh, okay.
I can use my pointer.
I guess I'm comic relief today. Okay, anyway, it was, on the left you see a map of Central California, and you can see up by San Jose and by Fresno, there's a lot of bright, hot pink areas, and those are areas where the viewing is terrible. But if you look over, let's see if I can do this without changing the slide. I don't think it shows very well on the screen. Okay, I'll point it out. there's this dark spot right here. And it turns out that that dark spot is very close to where we are here. In matter of fact, you can see, here's 198 coming out of Coalinga on their way to the 25 intersection, and there's a nice dark patch right there. So I thought, hey, this is an opportunity. I'll tell you about that in a minute. There's a thing about digital cameras that makes it really handy for taking pictures, because you used to have to get film, and then you wouldn't know what you had until you got the film developed, and by that time everything had gone by. But digital cameras are great because you can take lots of pictures, you can look at the results, and you can say, oh, I can change this and change that. And so this is what I've been doing, and since I started working with digital cameras, I've gotten some decent results, and I'm kind of proud of it. Used to be that with film, you couldn't take long exposures because the film actually gets less sensitive the longer you expose it, which is kind of an anomaly. But we don't have that problem with digital cameras because you can set them, you can set the sensitivity very, very high, and you can get things. So I will be able to show you some things that I got. Okay. I would say a digital camera with a zoom lens would be really nice. And you can just go out, point it at the sky, and you'll see a lot of stars. And then you can take a 1/4 second exposure, 1 second exposure. I need a tripod, of course. And they make a couple of programs for your computer. There's one called Starry Night, and there's one called Photo Pills, which tells you when the moon rises, where you could go to see certain things. If you want to take a certain picture, like with a silhouette, you can do that. And good subjects, the moon, of course, the moon and objects in silhouette, something with the moon behind it. And Milky Way is great. Comets, and meteor showers, and star trails. Okay, I own a software called Starry Night, and it has a free trial version that you can buy, or that you can check out. And you can do amazing things with it. You can pick a date and see what the sky is going to look like. You can run it in high speed and actually see the night sky before you. It's great, and I would just recommend, if you're really interested in it, to give it a free trial. Okay, so I took this one with my iPhone. They make an adapter that you can put your iPhone on, and it's not too bad, you can find the moon. It's real easy to find, and it's a short exposure because the moon is actually lit by the sun, so it's like a sunlit exposure. If you take like a 1/2 second, 1/4 second, even a 50th of a second, if you have manual settings on your phone, or you can just try different, take a shot, try something different, take another shot. Anyway, so this is something I did in my backyard. Okay, so I have this other program on my phone called Photo Pills, and Photo Pills actually gives you locations of where the moon, where the sun, where different things are. And so I said, hey, it'd be great to see the moonrise over Jane Avenue. It was going to be a full moon. So I used this software to tell me when it was going to be, when the moon was going to rise, and what date it was going to be coming up over Jane Avenue in that direction. And so that's what I got. That's not an eclipse. It's just really that yellow when you get down low in the atmosphere. Okay, also, if you go out Elm Street to Phelps and go across to the vacant lot that's across from where the road goes to the hospital, and you look east, that's where the moon rises. And if you look west, you'll see comets or things like that after sunset. So it's a great place to just try things out. And it's reasonably dark, although there are a lot of trucks going by. Okay,
That's why you took this comet picture, wasn't it?
I took that, yeah. Okay, so recently I read that there was going to be an occultation, which is a phenomenon where the moon passes in front of a planet. And it turned out that it was going to be in front of Mars, going to pass in front of Mars, and people get all excited about this because they say, oh, they can find out, see how long it takes, and anyway. So I went out to my backyard with my binoculars and I looked and I said, my gosh, here's Mars. And I have a long lens, and I was able to catch Mars just before the moon went in front of it. So it was thrilling. And it actually is red, just like that. I did catch this. This was comet Neowise about 3 years ago. I just went out by the skate park and just pointed it up and shot it. It was visible with the naked eye. And the one that's on your program was also visible with the naked eye. So just opportunities. Now, I was going to go out. I got up at 3 in the morning, and I was going to go out 198 all the way up to the top of the hill before it starts going down towards 25. And I got about 3 miles out of town, and I looked off to my left, and I said, my gosh, there it is. So I parked the truck, and I got out my camera, and I took several shots, and this was one of the best ones. And it really is that dark, and you can really see the Milky Way very well. So, something to do, something to try. A couple of years ago, we were in Hawaii, and I had this photo pills thing on my phone, and I said to my son, hey, you know, you can see where the Milky Way will be. And he said, well, didn't you see it last night? And I said, no. So that night, we went out, and between the palm trees, there it was. And that's just a regular shot, you know. So I was surprised that the sky was that dark on the Big Island. But in fact, I went up to Mauna Kea, which is where they have all the observatories, and it wasn't that much better. And I got altitude sick anyway, so it's a different story. Now, I did not take this picture. This was taken by Gina Lopez. She has a really fancy camera, and it's got something called image stabilization, so she could actually hand hold it. And a couple of years ago, we had an unusual conjunction that Saturn and Jupiter were like right next to each other in the sky, and that doesn't happen very often. And so she went out, and you can see them. There's Saturn, and there's Jupiter, and you can see four moons of Jupiter all strung out. And I think that's an amazing picture. I mean, that's what it would look like through a small telescope. I was sorry that I couldn't get the same picture, but I give her credit because it's amazing, really. Okay, there's another thing you can find in the sky. It's called the Andromeda Galaxy, and you can see it reasonably well with binoculars. It doesn't look like that, though. It looks like a big smudge. But anyway, if you can find Cassiopeia and you follow that triangle, you see two stars. No, I'm sorry, these two stars. And the galaxy is just kind of like, if you come back that way, the galaxy is right around there. And it's kind of fun to look for, as I said, with binoculars. Okay. You can't look at the sun during the eclipse very well, but if you have like leaves in your backyard, they act like little pinholes, and you can actually see that the light that's coming through is the shape of the eclipsed sun. So it's up to you. You just take it with a regular camera. And then Glenn was saying that I try and put up a star trail picture to show that there's truly a center of rotation where the stars are, and that Polaris is right in that circle, or it's like a 3/4 of a degree off, I think. But it's important because some people like to take really long exposures, and you know what happens if you take really long exposures? Your stars don't look like stars anymore. They look like lines, and they make trails like that. But people who like to take astronomy, good astronomy pictures, they use what they call a star tracker, that it goes backwards when the Earth is going forward, so that the image on the film maintains a point star rather than a trail. In conclusion, now what?